Okay, compositions, just like in functions, it just means you're going to do one and then the other, and you could do 8 if you wanted to, like we did multiple translations before, but we on this one, we're first going to reflect the figure over line K, and then we're going to reflect it over M. So because these are vertical, remember that all we have to do is move to the right and then keep moving the same amount. So I take U, I have to go 2 to get to the first line, so I just keep going 2 more. U prime. R, I go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. T is going to be also 6 because it's on that same vertical line. And N is going to be also 2 because it's on the same one with U. Okay, so there's trapezoid number 2. And then I'm going to flip it one more time over a different line. So R, to get to that line, 1, 2, 3, 1, 2, 3. There's R prime again. U goes 1, 2, 3, 4, 5, 6, 7. 1, 2, 4, 5, 6, 7. N is also going to go 7. And T is also going to go 3. So we end up with this. And if you just consider, well, the first question is, what do lines K and M have in common? Well, they're both vertical, and you can tell that because they travel up a single x value in both cases. They go right up and down the grid. So they're parallel. So a composition of reflections over two parallel lines is really what? So if you look at the thing you started with, the term, trapezoid, and you go to T prime, well, I guess it's not turn, it's T run. So T prime, R prime, U run, prime, N prime. It actually looks like we just moved it over. So it actually looks just like a translation, like we just shifted it. So it's really a translation, and not even a particularly interesting one because it didn't even go up or down. So it's really just a horizontal translation. But if it had been, so this is in this case, horizontal. If these lines had been parallel, but they had been, say, horizontal, then it would have been a vertical translation. And if these lines had been parallel, but they had not been vertical or horizontal, then it would have been a true, a translation that was more interesting. It would have gone sideways and up or down. Okay, so this one we want to first reflect it over the x-axis and then over the y-axis. So over the x-axis first, down to the x-axis, keep going, down, keep going. So then we have that triangle. Now we're going to take that one and flip it over. Pick a new color. Then over the y-axis. So from here, go 2, go 2. From A, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is now P prime. This is now A prime. In 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. N prime. Okay, so what did we really do? So the first thing is we went over the x-axis and the y-axis, and the first question is, how are they related? Well, if the lines we just did, what we talked about was parallel, then the thing that makes sense to talk about with the x-axis and y-axis is that they're perpendicular. So if you go over two perpendicular lines, ran out of space, then what have we really done? Well, we really rotated it. If you look, it's just like we spun the paper around. The first one didn't look like a rotation, but by the end it did. So this is really a rotation. Okay, so this one we want to go over the x-axis and the line x equals -1. This ought to look like a rotation because the x-axis and the line x equals 1 are perpendicular. Here, or -1. So here's, whoops. Here's x equals -1, right there. So we reflect it first over the x-axis, so up 1, same, up 1, 2, 3, 4, 5, and the same. And then we're going to flip it over this line here. Well, that one's on the line, so it stays where it is. That one moves 1, so 1, 1, 2, 1, 2, 1, 2, 3, 1, 2, 3. And it does look like a rotation. The one before looked like a rotation around the origin. This one looks more like a rotation around this point here. Okay, so there's another kind of composition that has its own name. Glide reflection. If you look at these images, each of these are made from a glide reflection. So, get F, move it over, flip it, move it over, flip it back, move it over, flip it, move it over, flip it back, and so forth. Same with the flowers, same with trapezoids. So a glide reflection is the composition of a translation, and a reflection. Okay, so we're going to translate and then we're going to reflect, and this ought to cause a glide reflection. So we're using 0, -4, so we don't go any to the left or right, we just move down. So 1, oops, good grief. Okay, so we go down 4, down 4, down 4, and then we reflect across x equals 1, which is this line. Change pen color. This one's on the line, so it stays. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. And that's that. So A prime is 1, -2, so this is A prime. B prime, C prime. So A prime is 1, -2. B prime is -2, -1. C prime is -3, -3. And this one we're going to translate using 6, 0, and then reflect across y equals 1. So here's y equals 1. So step 1, we move this thing to the right 6. 1, 2, 3, 4, 5, 6. Same. 1, 2, 3, 4, 5, 6. So there that is. And then we reflect across this line. So up 1, 2, 3, 4. 1, 2, 3, 4. Up 2, 2. 1, 2, 3, 4. 1, 2, 3, 4. So this one's E prime. This one's F prime. G prime. So E prime is 1, 2, 3, 4, 5, 3. F prime is 5, 5. And G prime is 1, 5. And that brings us to maybe the last thing we're going to do in transformations. I know you guys did tessellations last year with Miss Walters, and we'll discuss them again next year. So they're super cool, interesting things, and if anything, I love it if you just make one. But I'm not sure that we need to spend time on that this summer. So I think that perhaps we'll end this section with dilations. So I'll stop here and then I'll start that.